Good evening all, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments Australia. Tonight we are really excited to bring you IB Back to School Essentials. My name is John Bayman and I am your host for this event. I teach mathematics to Year 7 to 12 students at O'Loughlin Catholic College, Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. I'm more excited to introduce our panelists for this evening, Miss Bajana Graham. Good evening, Bajana. There we go.
Good evening, John, and everyone. Sorry.
I was a bit worried that I was on my own for a minute, but it's lovely to hear your voice.
No worries.
As you can see, Bajana is a very talented mathematician. She's a fantastic senior mathematics teacher at Wesley College, Melbourne, and likes to continually challenge herself and share her knowledge with others through key roles with VCAA, IB, MAV, Pearson's Australia, and Promote Your Education. Bajana, thank you very much for joining us this evening.
Pleasure.
I have to say, when I read that, I wonder how you find a moment to do anything else.
We'll start by introducing the new operating system 4.4, which was released a few weeks ago. There isn't many major changes. Probably inverse binomial is one of the main changes. Other than that, we still have relations and control menu for quick access to some functions, which I will talk about later. So what I planned for today is talking about how to actually connect to Press2Test via Navigator and Teacher software, and it can be done either wirelessly or via docking station. Then we'll look at using sliders to introduce problems with parameters and how to check the solutions, using regression functionality for some basics, equations, and maybe for weaker students like in studies, that's very helpful as they always have calculators. Calculus features graphically and numerically, including sketching gradient graphs and finding when gradient is 0. Again, we'll talk about those main features, numerical solve, linear solve, and polyroots. Probability, I will look at negative inverse binomial because it is a new feature. Maybe, if time allows, a bit sequences and series. We'll look at some graph features like define graph and trace, and also looking at the tables, and geometry features and some trig functions as well. So what I want to do, I actually have a virtual class connected. So as you see, I have one calculator connected. And if you have the students connected, so it can be actually via a navigator like that, or you could just connect them via docking station. If you press Tool and go to Prepare Handhelds, we have those bottom to enter Press2Test and exit Press2Test. So if I go to enter Press2Test, this screen appears. I have it already pre-done, saying that I unticked all the things which needs to be unticked for Press2Test mode, and we know students usually have big difficulty remembering which one to do. I saved it as IB exams, and that's in radians. We might change to degrees, and then we might save that as, let's say, studies, because studies should always be in degrees. So then you have options when you transfer, when you want to put all the students' calculator before test or exams, you can easily do it. So I will try just to do it live. So we go and we go enter Press2Test, and then if I go to my documents and then I press here, so I can see this calculator, which actually is now getting into Press2Test mode. So it might take a second because, as you know, it takes a while to get in Press2Test mode, but this is how easily it can be done. And then when we finally get to Press2Test mode, we'll try to see what features are actually available in Press2Test mode and which are not. So hopefully we're getting there.
So on your calculator at the moment, Bojana, is it still sort of going through the
it is
adjustment?
getting into press-to-test mode. It does take a few seconds, but I think it is important to actually show what the calculator looks like. So yes, starting now. So if I have to start, so enter. So let's see whether it will actually work. So now you see that it's locked. So also you see the display is different. The student which has this little lock means that their calculator is in press-to-test mode. And if I now, you'll see in a second what happens. I'm just starting. And if I now make live presenter, so you will be seeing actually the handheld. So if we go to menu on my calculator here, and I can do all those things, but important thing is if I go to function, which is graph entry, and you see that some things are highlighted, some are not, but it is a bit misleading, because if I want to go to the relation in press-to-test mode, I might sketch y equals x, which basically is the same as the function relation. But if I try to do in the relation, let's say x plus y equals 3, and I press enter, it will tell me press-to-test graphing restriction. So it is good to be aware that sometimes things are highlighted as here, but only part of those features will be available. Interestingly, we can sketch, which is not that useful actually for IB, you could sketch, shade the region inequality y greater than 2, but you wouldn't be able to do the same with x. So this is just something to be aware. If I want to do, let's say, less than 1, it will give me the same instruction. Also, if I open the calculator screen, and if you remember in 4.3 there was new thing introduced, let's say equals 4, and if I press control menu, actually it is still working in press-to-test, so that's quite interesting. I thought it wasn't. So this is this new feature. You can enter something and the calculator is guessing what you want it to do. So it works entering x squared equals 4, and control menu, you could see that it asked me what I wanted to do here. So I will stop the presenter and go back to documents, and in the same way you could actually exit or the students from press-to-test mode, which is quite handy when we can do that via the navigator or the docking station. I pause class because we won't need that anymore and go back to the calculator. So let's have a look at some basic features. So I have a few prepared files here. So polyroots, which we can find in calculations and algebra, polynomial tools, and we can have real or complex roots. It looks a bit differently, as you could notice, because it is in the notes page. So if I try to solve this equation, it gives me the two solutions written in this way. However, this, of course, will not give me other solutions because discriminant is negative. And here I would need to use C polyroots, which gives me the solutions as complex numbers. So that is one of the features on the calculator. The other feature I will have a look at now is looking at using some regression on the calculator for getting equations of straight lines, parabolas, sometimes other functions, but those two are quite basic. So let's say we want to find the equation of a straight line through 2, 1, and 5 minus 3. I will do this one live. So I will open a spreadsheet and I will say X here so that we put the variables on the top, and we had the points 2 and 1 and 5 and -3. So we need to enter those 2 points. Now we can do the regression in the spreadsheet, but I think it is easier to do the regression in the calculator screen. So we go menu, statistics, stat calculations, and we do linear regression. I need to tell the calculator my variables. Why? The advantage of doing it is that it saves the regression equation as F1, so you can actually plot it, whilst if you do it in the spreadsheet, that doesn't happen. So I have this regression here, but the numbers don't look very nice. I have fractions, and like for study students, they would probably prefer having, not decimals, but fractions. So if you press variables, you can find the statistics like M. It still gives me this value, but if I go to menu, number, and approximate to fraction, it will actually change the decimal to a fraction. So for weaker students, it is quite helpful finding the equation through 2 points, like in studies they always have calculated. And I could do the same with statistics B. Once you do the regression, all that stays in variables there. And then again, I can approximate it to fractions. So I have those two as fractions, and in studies they often ask to express the straight line in general form, AX plus BY plus C, so that's easy if they have those two fractions written this way. The other one we can do in a similar way, and actually if I go back to this document, so as I said, it saves the equation in F1, so if I now take the calculator and go up, this equation is there, and we can use this equation if we need for something else, so this equation would be sketched. So this is another advantage. So this equation is also for like standard level or studies questions and good practice with the regression. Find the equation of a parabola with vertex at 1, 5 and y-intercept at 0, -1. So it's good for the students to know that for a quadratic regression they need 3 points, so they need to find the third point using symmetry. So in similar way, we get 1, 5, 0, -1, 2, -1 from symmetry, the third point. This time I did the regression in the spreadsheet using the same feature statistics, stat calculations, but this time choosing the quadratic regression and also entering X and Y. You can also notice that I have different numbers on the top, so for each question I insert a new problem, so that's how it's done, and that is good for the students because then the variables can be new variables in each of the problems. And they sometimes use frequency as F and they repeat the same things, and something which is predefined they get in trouble. So this is this quadratic we have got, again, as the regression line. And here, to check that they've got it right, we can use trace and graph trace. So if we enter 0, it gives us 0.01, and the other point we were given was 1. So that's the vertex, and the other point we chose from symmetry was 2 and -1. So the graph trace is a very useful feature because you can get the point straight away. The other useful feature, of course, is Control T, which is the table. So if we press Control T, the table appears, and then students can read all the values quickly for this quadratic here, but for other functions as well. And if we press Control T, again, the table disappears. So again,
That's
I
a
got
lovely
those
little feature, isn't it?
statistics. Yes, it is. So I got those
Yeah.
statistics now, A, B, and C for a quadratic, and it is again stored in variables. And not all the students realize that this is the case, that those things can be actually grabbed from there and used. Now I'll do something graphically, so let's have a look. We have the velocity of a falling object in C is given by this exponential function, where t is in seconds and v is meters per second. So we want to find the initial velocity, velocity after those times, graph the velocity function, and write down the terminal velocity. So could be a standard level question. So if I again go to this document to do it live, and then I will insert a new problem, and I start with the calculator. For study standard level, even high level, it is a very good habit to actually define the function. So if I define this function, I say v in t equals, and we type 6 times bracket, I will just type it here, 1 minus. Now it has to be e to the power. So one of my students asked me, oh, can we just type e? I said no. We have to definitely use this one, minus 0.8. Here I can use t. It's fine because I said v in t and I press enter. So the advantage of defining the function, of course, is that I can now find v in 0 and it appears bold, and as it asks to find v in different values, and that was in the other document here. So let's see what happens if we actually go v in 5, then we can go v in 10, and then we go v in 20. So you might ask students, is it really 6? Or not quite. It is approaching 6, but it's not quite 6. So that's the idea of the terminal velocity, and that's the way to introduce it to the students. So now if I want to graph it, I can use what I defined, but of course if I graph, I need to change it to v in x. And we can play with the window. And again, if we do Control T, we can see in the table that those values approach 6. Again, after a while, it will be showing 6, but because it's rounding off, but you can see here the full display on the bottom. So this is just numerically arriving at terminal velocity. So that's a nice feature as well. And of course, we could do trace in the similar way. So if I want after 10, it will get me the point. So that was one of those features, trace, graph trace, and defining, especially for the study student. I think define with all those unfamiliar functions is a very, very useful feature. Now, we usually talk about numerical solve versus graphical approach. So again, I have those things showing here in the notes pages. So we know if I have the exponential and the straight line, they will only intersect once. So the solution here is accurate. However, if I numerical solve exponential with this particular quadratic, it will only give me one solution, the solution closest to 0. Of course, I could trick the calculator and ask what happens if it's less than 0. So I need to add this extra condition, which you get given that and the values by pressing Control equals button. But it is definitely not the most efficient way of using the calculator. So it's always recommended for the students to actually graph both functions and find the points of intersection graphically, because now clearly we can be sure that there are only 2 points of intersection, and with some complicated graphs, well, using trial and error with numerical solve is definitely not the best idea, and those things are actually tested during the exam as well. So another thing which I would like to look at is looking at parameters. And here we have a quadratic equation with a parameter k. And the question is, for what values of k this quadratic equation has one solution or no solution. So if I want to do it live, and again I go to my document and insert a new problem, I don't get any interferences here, and I will add the graph, and I will actually enter the quadratics x squared and plus kx, k we need to go times x because that's not the variable, and then we go plus 2k minus 3. I mean, we need to have times, otherwise it treats it as one variable. So if I press enter in operating system, was started from 4.2 I think on, the calculator recognizes that k is a parameter and it will create a slider automatically. So I'm saying yes, I want a slider. If you go here on the calculator, it's control menu, on the computer is right click, so we can do the settings. So I will change that to, let's say, 6, and we'll do the automatic step 1. If you scroll down, we can minimize the slider because that looks nicer. So what happens now, we can change the values of k just to illustrate the idea that we have two solutions, then we have one solution, and then we do more values, and then we have one solution again. So no solutions, two solutions, and so on. So of course it's a good graphical representation. What happens to the discriminant? So of course in standard level, high level, they would calculate discriminant and solve it for 0 to get those two values, 2 and 6, and then if we want one solution, no solutions, we would make it negative, the discriminant negative. So this is a nice feature, solving things with the parameter. Go back to my main features, and that was what I just did. Now, movable lines is the activity which I have used in my classes, and Peter Fox is adapting it to put it on the Australian and New Zealand website. And there will be teachers' handout and will be students' handout as most of those activities. So this one is a bit more complicated. So we have two linear simultaneous equations, and k is again any real constant. And we would like to answer finally the question, for what values of k the system has a unique solution, no solutions, or infinite number of solutions. So again, the calculator will not solve with the parameter, but we can do a few things. So in the similar way, we can sketch the graph, but what I've done this time, I actually used the relation, okay? So my graph was a relation because I entered the equation as it is, 2x plus k plus 1 times y equals 6 and kx plus y equals 3. This is good for the class activity, not for the exam, because in the examination they will not be able to enter relations of this type. But for the class activity it is good. And now if we change the value of k, we see unique solution here, unique solution again. We go the other way. Oh, we have infinite number of solutions. And if we go this way, we have no solutions. So that gives the students some idea what actually happens with two straight lines. Algebraically, they would need to get the gradient of each line, equal the gradients, and solve for k. This would be a quadratic to get those two values. And then substitute back and see when we have the same line and we have two different lines. So this is quite a nice activity as well. Then to follow after that, we have this linear solve feature on the calculator. Again, it will not work unless we predefined the k value. So since we already saw that something interesting happens when k is -2 in the slider, and then also when k is 1, so that's why we say let's k will be -2, and then we use linear solve. Linear solve can be found in solve system of linear equations. And if you do that, it will ask you how many and what are the variables, and it will come up with the template like that, so it's easy to enter those equations. So in case -2, the calculator will return no solution found, and then we see the two lines were parallel. Then we make k equal to 1, and then you can grab the same thing and just copy it down here, and we get an interesting answer. We get the parametric equation of the straight line, which tells us there is infinite number of solutions because we actually have the same straight line. So we say that this is how it is expressed. So we can make yt and x equals 3 minus t. But again, it is a nice thing that students can actually experience what happens with those two straight lines.
Those visuals are very powerful, aren't they, Brianna? It's fantastic.
Yes, my students really like that, and they understood what was happening. So algebra comes later, but that it is about the understanding what happens. Similar could be done with 3 equations, but we have planes, so that is a bit complicated with the parameter there. But once they understand what happens with straight lines, it can be extended to what happens with planes. So for what values of x, find the values of x for which the gradient of the function is equal to 0. So of course for the studies against students, they should be able to differentiate 3x squared minus 6 is 0 and then trying to solve. On the exam they will ask for the derivative, but how they actually find when the gradient is 0 is open. So let's see what would be the easy way of doing that. I'll be using again new problem, and then I will use the calculator, and then I will define the function. So again we go menu, actions, defined, and my function is f in x equals, so we start with the easy one, x cubed, and it is minus 6x. So I have this function defined, and now I can open the calculator screen and I can sketch the gradient graph straight away. So I need the template, and I'm using ddx here. So I have dx, and my function which I defined was f in x, and it comes bold. So this is the gradient graph drawn, and we are after when the gradient is 0. So we just need to get those 2 points, and it will be symmetrical. So that's an easy way for the students to get the numerical values if they ask for them, and studies will not be asked for the exact values. They will always be asked for the numerical values when the gradient is 0. We can also look at a similar question here. That was the one we just did. But if I have another function, g in x, which is 2x plus 4 over x, which I defined, what we can do, we can sketch the graph of g in x, showing our stationary points, and then we can sketch the gradient graph on the same set of axes, matching the x-coordinate of the stationary points or turning points here with 0 gradient. So that enhances this understanding that when we have stationary points, the gradient is 0, and we have both graphs drawn on the same set of x's. So another feature which is very nice to use is for the construction equation of a normal. We can do it in the class time, but the construction will not be available in press to test mode. However, we can find the equation of the tangent. So our function here is 3x plus 1 on x minus 4, and we want the normal at x equal 1. So just for the, again, understanding how the, the things work with the tangent and the normal, if I go again to do it live, and we have a new problem, and we'll start with the graph. So we have 3x plus, use the fraction 1 on x, and minus 4. So this is the graph. I might change the window slightly to see more of the graph here, because that will be easier to construct this tangent. So now we know that this feature, geometry, points and lines, we can do the point on intersection points, and we can definitely do the tangent. So if we want the tangent, we want the graph, and now it's asking for the point. So to get the point, we need to open the bracket and enter the value. So it is a bit tricky initially for the students, but after the while they get the idea how to do it. The other way, which probably is a bit easier, would be we can go to geometry again, points and lines. We can do the point on, put any point on and enter, and then escape, and we can redo this point as 2. So now, having the point, if I repeat menu, geometry, points and lines and tangent to the curve through the point, it is less tricky doing it this way. And that is the equation of the tangent at x equal 2, and this is at x equal 1 because we've entered that. We can get the coordinates in not press to test mode. So if I go to here, I can get the coordinates, but this functionality actions coordinates is not available in press to test. So again, something worth noticing. So now if I want to construct the normal, we need to go to geometry construction, and I want to draw a perpendicular line to the tangent through the point. It doesn't look perpendicular because I need to do the square a bit more, so now it looks perpendicular. So that's the construction of the normal, again only available for class activities, not in press to test mode, and I can find the equation of this line just to show the students the relationship between the gradients. They should know that the product of the gradients minus 1, but for the weaker students it is a good enhancement of this particular concept.
Vijana, we've just been asked a question.
Yes.
Where do you recommend normal class time using the calculator in press to test so that students understand what they can
get? No, definitely in the class time I would do much more activities just to introduce new concepts, enhance understanding, but making students aware that some of the functionality is not available in the exam. But for understanding and for practice, and for class activities, it is really a nice idea to do something more, but they need to know that in the press to test they will have to do algebra much more themselves, like here to find the equation of the normal. Yep, it's fair enough. They can easily find the equation of the tangent, but then they will need to calculate the gradient of the normal as minus a half or minus 0.5, and it passes through the same point, 1 and 0. So if they only are given x coordinate, they can easily find, and if we put 1 here, it will give us the y coordinate as 0. So they need to go y minus y1 is m normal x minus x1 and do those calculations algebraically. But it is still good to actually draw it on a calculator to see what this normal is if they doing questions like that for the first time. Does
Lovely.
that answer
Thank
the
you.
question? Okay.
More than adequate. Thank you.
Okay. So I will come now to just to explain what is new in the probability section. So this is the binomial probability question. Jack shoots arrows at a target with probability of 0.3 and any single shot. All shots are independent, and this is a typical question. Calculate the minimum number of shots required for the probability of at least one shot hitting the target to exceed 0.99. So in the past we would start doing that, x greater equal to 1 greater than 0.99. Then we replace this 1 minus probability x is 0 greater than 0.99. And then we have probability x equals 0 is less than 0.01. And that would have to be solved using the binomial probability formula. However, now we have another option of doing that. So if I go back to my document and go to the calculator, and now I go menu, probability, distribution. So if we scroll, we see that there are two things appearing. We have inverse binomial. We use this one if we want to find x values given probabilities, and inverse binomial n, that's the one where we want to find the number of trials. So if I choose inverse binomial n, it is asking me for the cumulative probability, which we said in our equation we always go from the left, so we would need to say it's 0.01. Looking at the equation we derived, the probability of the success is 0.3, and we said that we want 0 here. Now, that can be displayed in two forms. If I don't actually tick the matrix form, but I tick OK, it tells me that I need 13 trials, okay, for this to happen. However, if I do it again, and I enter the same numbers, but I will show you what happens if this time we use the matrix, 0.3, and we want 0, but this time I put a matrix form, so now it displays things. It shows me that if it's 12, it's 0.0138, so it's not quite what I want, but with 13 trials, the probability that I achieve at least one with the probability more than 0.99, I need 13 shots. So this is one of the questions which can be done on a calculator now. Important thing to remember is that the questions inverse binomial n cannot be used if the comment only refers to probability x is less equal to a particular number, not in between or not greater. So the other one which is there is just inverse normal. So if I come back to some of those in a second. But inverse binomial is to find x the number of successful outcomes given probability of a success, the number of trials, and probability that x is less equal to x. So let's have a look at this example. Jack shoots 10 arrows at a target with probability of 0.3 of hitting the target. All shots are independent. find a range of successful outcomes for the cumulative probability to be 0.9556. So this time, when we go there, we actually choose inverse binomial, and it will ask you same questions. So we put 0.9556, 10, and 0.3. So it says it's 6. Or if we use the matrix form, it will tell you that if we have probability x is less equal to 5, we only get this cumulative probability. When we go x is less equal to 6, we get the probability of 0.984, and so on. So this is one of those features on the calculator which are new, inverse binomial for finding the x value for the cumulative probability, and inverse binomial n when we can find how many trials we need to achieve a particular probability. Again, those things can be done slightly differently. So what I will have a look at now, it's again Harry shots 10 arrows with probability of 0.6. All shots are independent. What's the minimum number of shots needed for the probability of Harry hitting the target exactly 5 times to be more than 0.25? So what we can do here, we can actually enter the function in the graph screen, but I might start with looking at this screen. We can define binomial in N is binomial PDF. Where do we get binomial PDF? If we go to catalog, we have binomial PDF and binomial CDF, and it tells you the syntax. So we want number of trials, probability of success, and possibly X value, but for our definition, we defined binomial PDF, N unknown 0.6, and number of trials 5. And now, of course, once it's defined, you can find what's probability in 5, 6, 7, 8, and then we might look what answer was asked and how many we need. So that is our question here, our answer here. The other way it can be done is by, once you've defined that, you just can display it in the spreadsheet as well. And in my handout, they are detailed instructions how to do it. And then you can scroll up and down and see the probabilities with this definition. Another thing we can also do is we can sketch the graph of binomial CDF, and this is a step graph which shows you the probabilities for different numbers of trials. And then if we want a particular probability, as we started with this other question, we might see, even using trace here, we can just skip through different points and see what probabilities on the bottom of the screen we have. That's a bit more complicated, so again, you might think whether you want to do it with your students or not, but there are some possibilities of doing those things there. Okay, inverse functions problems. So if I look at the PowerPoint, the idea here is that, of course, students learn how to find the equation of the inverse function, and they should be aware that the functions and its inverse are symmetrical in the line y equals x. So I skip all those introductions, how we teach it, but then this is quite a nice activity that once they actually get their equation, they can check whether their equation is correct by using relation to sketch the graph of the inverse and then entering their own equation of the inverse and checking that those two are the same. So this PowerPoint is in my files as well. So what we start with a particular graph and then draw the inverse. So I will draw this again in the document to show you how that can be done. So we go to graphs and we enter the graph 2 and we have ln x plus 3 and plus 4 it was. So I've entered this particular graph in the function entry. Now if I go to menu and change it to relation, again it's only available for the class practice, I can say that now I want the inverse, so I want x equals f1 in y. So I want the calculator to draw the inverse function. That's this concept of swapping x and y values. So the calculator draws the inverse function. Then the student, of course, needs to rearrange the equation and enter the rearranged form, which is 2e to the power, oh, that's actually not this one, sorry, here, which is e to the power x minus 4 on 2. And if their graph actually is the same as the graph which was obtained here, they match, and also they can, of course, see what happens, that there is this symmetry. So if we, what happens here? Control wrong button. Y equals x, so they can see that it is symmetrical, and we can change the window to see the other point of intersection if we need to go maybe a bit higher. And they can find the points of intersection, and that looks nice and symmetrical. So again, I'm saying if they enter their own equation, if in graph entry and they are the same, that means that they've got their equation correct. If we're using the function relation and you want to find the intersection, it is slightly different because I want this and that. It gives me the little square. So this is just a slightly different thing of doing that. So just in case you do that, and the questions would ask, because this is drawn as the relation, not as the function. But if they enter their own equation, then you could use the same intersection. So that is a nice activity on inverse functions.
Bijana, do you worry about the window not being square, or that's not really
yes, I think probably for inverse functions would be nice to have a square window. Good point, but sometimes, yep, that looks better, and because it shows this symmetry better. Yep, so that's a good point. Using square on the calculator, we can get the square window. Now, before we finish, I might not have time to actually do this construction on the calculator this time, but we might maybe leave it till next time. A few other things I would like to touch for the last 5 minutes. So if I, again, insert a new problem and have a calculator, and we have trig, and let's say I go sine, and I want to enter 30 degrees, but I'm in the radian mode. So I press this button and press degrees and enter and get the value. So students are always worried. You could change even in press to test, of course, between settings, but that's one of the things which is nice. We could also do, let's say, inverse sine of 0.2 and enter, and that gives us the radians. But if I use this and use decimal degrees, it will change it to degrees. So that's one of the things which are easy for the students to have a look at and not being scared that I'm in a particular setting. For studies, it's always degrees, so there wouldn't be any problems. High level and standard level, they really need to be in radians for graphing, sketching graphs and doing most of the calculations, but when it comes to, of course, using sine, cosine rule and the like, then it is better to do it this way. Now, the other feature which is quite nice on the calculator is sequences and series, and all three studies do it, high level, standard level, and studies. So if you go to the catalog and scroll down, we have a sequence, and here we have expression, variable, low, high value. They can later just type, so let's say our sequence is 2n minus 1, the general term, the variable is n, and I want the terms from 1 to 5. I did something wrong. It should be that, and it displays the sequence. If I want to find the sum of this sequence, so I can go sum, and I can either take that or the original, and it will add it. We also have a sigma notation, which is available in pressed to test mode. So if I go in 1 to 6, or I had 5, we might do 5, and then we put 2n minus 1, and we get the same answer. I have one little activity here, so this is just a poll. Consider the arithmetic sequences, this one and this one, which is the next number after 2005 that appears, oh, there's a mistake here, in both sequences. So you can send it to the students and ask them, saying you can have the calculator, but to illustrate what can be done, we can enter both sequences, and of course they are arithmetic. So once we have the same number to start with earlier, 2050 and 2050 there, then after that one increases much higher than the other, but if you scroll you can see that both will have the same number there. The smarter kids would say that you need to multiply one difference by another and add to the original number to see when the next number will be the same. And they could also, once you enter the sequences, they could solve, and they would see that it happens at the start, but then never again. A quick last one about the chi-square for studies, which of course is very big thing for statistics. So using the chi-squared, using the matrix entry and saving, and then the matrix entry can be found here, and if we choose that, then it asks number of rows and number of columns, and if we want to perform the chi-squared, we go to stats test, and we use two-way test, and just enter the observed matrix. So I have done that here, and as we can see, we get the chi-squared value, we get the p-value, degrees of freedom. Once the chi-squared was performed, again, we can get the expected matrix, so they can check whether the calculations were correct. We can just get those values separately, and the p-value, which is often asked in the exam to compare it to the significance level. So if we're testing at 5% here, of course, it's not good enough. There is also a way to get the inverse chi-squared, which only really matters for the project, because in the exams they would do it. So if we go 0.95 and degrees of freedom 6, so it will give us the chi-squared value. So I think I stop at this point. Thank you very much for listening, and I will stop sharing my screen and back to John. Thank you.
Wow. Thank you so much, Bojana, for such an informative webinar. And so impressive that you've had us transfixed for nearly an hour. Thank you. So we're going to begin wrapping things up now. If you have any last-minute questions, please try and get those asked. As I know, Bojana will endeavour to have them answered. Or we can also have it for future webinars that I'm sure Bojana would love to run and to share more information with you. As you can tell, she's a very knowledgeable young lady. When you leave the webinar tonight, a brief survey will automatically appear here in your browser. Your feedback guides us as we plan future online events. We listen to your feedback, and so we hope you share your thoughts in a post-webinar survey. Your certificate of attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and YouTube version of the recording, as well as any other relevant documents that Bojana mentioned this evening. After we leave tonight, if you need some post-webinar follow-up, feel free to phone or email us. We'd love to hear from you. And that brings us to the end of tonight's webinar. Thank you so much, Bojana, for everything you've shared. I really appreciate it.
Thank you, John. Thank you, everyone.
Thanks, everyone, and we hope to see you back online soon. Have a great night. Good night.
Good night.